Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's up, automotive world? This is the Automotive Diagnostic Podcast. My name's Sean Tipping. I'll be your host today for the show. Thank you so much for tuning in for another episode. Today on the show, I'm going to walk you through another case study of a vehicle that I recently worked on. This is a 2006 Chevy Suburban. But before we get into the case study, I just wanted to make one note. I was recently invited to go on a different podcast. This is the ASOG, or Auto Shop Owners Group podcast, that's hosted by Lucas Underwood, who was a guest on the show a couple weeks ago, if you remember, and David Roman. And they've just launched this podcast recently, and it's geared more towards, just like the name implies, automotive shop owners. But odds are there's a few of you out there listening that play that role along with technicians. So if you'd like to check out this podcast, I definitely recommend that you do so. And I will include the link in the show notes so that you can go check out their podcast. And you can check out the episode that I was on recently where we talked about education and hiring technicians in the automotive industry. So now that we covered that, let's get into this case study. Again, this is a 2006 Chevy Suburban. And the reason that I was called into a shop to look at this Suburban was that the radio was staying on after the key was shut off. Okay, so we take the key out of the ignition and the radio stays on. Now, if you're familiar with GM vehicles for the last, 20 plus years, this is normal if you don't open the door. They have a retained accessory power relay, a wrap relay, that keeps everything on for up to 10 minutes if you don't open the driver's door. And most technicians are aware of this. And I'll just say right away, this was not the cause. It didn't have anything to do with the driver's door switch, because I have run into this before. I've actually experienced this where the door switch is the problem. Of course, if that's the case, you could open one of the other doors on the vehicle and it should shut down the system. Again, not the case here. So again, I was called into the shop because they were having some trouble figuring this one out. And they had put some parts in this in attempts to repair it. Everything that they'd put in had been unsuccessful. The things that were replaced was the driver's door switch. Okay, so that actual latch assembly that has the switch to tell the vehicle, is the door closed or open? They had replaced this because, again, they were familiar with how the system normally works, and they thought that might be the cause. Of course, it didn't change anything. They replaced the ignition switch, they replaced the body control module, and the power distribution center, which is the fuse box under the hood. And at this point, he was saying, hey, we've got close to $800 in parts in this thing. Can you come tell us what's going on, because we still have the same problem? It's really frustrating. Okay, so I'll check it out. First thing you want to do, of course, verify what's going on. It's pretty easy to do in this case. This was not intermittent. This was all the time. And you could take the key out of the ignition, completely remove it, and of course the radio would stay on. I did notice a couple other things as well beyond the radio. The backlights for the dash illumination was also staying on. In addition to that, the battery light on the dash, the indicator that would say your battery's not charging, was also on. Okay, so we had a few more things than just the radio, but the radio was on. You could turn up the volume and listen to it, and door position made no difference. I tried a couple doors and really didn't seem to change anything. So first thing I did, of course, basic visual inspection. I didn't see anything. Looked like they had some things apart. I wanted to put the original BCM back in this vehicle because they had a used BCM that they had put in, and they had not programmed it yet. So, of course, Obviously, I could have programmed it and went with that, but in this case, I have a feeling it's not going to change anything because even a unprogrammed used BCM, if it fixed the problem, you should see those lights go out. It shouldn't have the exact same thing going on with it. So really what I want to do is just get the original BCM in this thing. And if it ends up being a BCM issue, sure, I'll put the used one that they have in there back in and program it to the vehicle if it's the correct BCM. You got to watch it with used BCMs. Even on a vehicle like an '06 where used is okay, there's so many options. If you don't get the part numbers correct, there can be a lot of problems just because with these specific trucks, they have so many different options. But either way, I kind of want to eliminate that right off the bat. And I just want to plug in the original BCM. Let's start from scratch. Of course, I do this and it's the exact same problem. So I'm kind of leaning towards, well, this isn't the BCM's fault. It's not a problem with the BCM unless somehow we have some really odd circumstance where they both have the same problem. Unlikely. Anyways, let's proceed. Next thing I want to do, let's plug this thing and give it an all system DTC scan. And I realized, okay, I unplugged the BCM, and so there could be some code set there for what I was doing. But let's just see what we've got, and maybe I could clear some stuff out and see if anything pertains to the problem I'm having. And although there were some codes in the vehicle, nothing really related to the issue that I was having. So at this point, what I want to consider, because the radio's on, we've got dash backlights on, we've got a light on the dash. I want to consider that there are multiple components being powered up here, just like if I had the key maybe in the accessory position. Okay, so if you put the key into the accessory position, where in this vehicle it's just one click past the lock position, you are going to have multiple components that stay on. That would be your radio. It ends up being your dash as far as the lights and the battery light goes, but there's also stuff like wipers and windows. This is all stuff that's powered up by that wrap relay or the retained accessory power relay. This is the same stuff that would stay on if, let's say, I were to start the vehicle, drive it around, go park it, have all the doors closed, and turn the ignition completely off. For 10 minutes, these same components would actually stay activated. And GM's been doing that forever. That's nothing new. But what I want to consider here is going back to that, all these multiple components that are powered up, is who's in charge of that. And this is a point that I wanted to make, and kind of why I wanted to talk about this on the podcast, is that we need to consider in modern vehicles. I mean, heck, this is a 2006 vehicle, so we're talking 14 years old here. That's hardly modern, but I see this more and more often. And we want to consider who is in charge of turning on all of these components, especially within the body of the vehicle. And you can even go beyond that. You can go stuff under the hood and headlights and wipers and all sorts of stuff. Who's in charge? And it's going to be what at least GM refers to as the power mode master. All right. Whenever we have things that are turning on when they're not supposed to, or even the case when things aren't turning on when they are supposed to, that wasn't the case here, but that can happen. We want to consider who's in charge of doing all this. Now, if we go way back, 90s and earlier than that, that was generally the ignition switch, right? When you turn the ignition switch off, it cuts power to all of the components. When you turn the ignition switch on, it's going to power up all these components. So that was kind of our power mode master. Which power mode is the vehicle going to be in? On, off, accessory, run, crank, whatever it might be. Pretty simple. But now in vehicles, we have a module, a control module, who is in charge of regulating power to multiple devices and basically determining the ignition state switch, if you want to consider it that way. I mean, obviously there's a physical switch, but in most vehicles nowadays, that ignition switch is just an input to a module. In this particular Suburban, the switch actually does send power to several components, like actual current to several components, but it also feeds the BCM, and it's an input to the BCM. And I guess that's a spoiler alert. The BCM is the power mode master in this vehicle, but it sends power to the BCM in different ignition key positions to tell it this is where the key is. This is what power mode the driver of the vehicle is requesting. And then the BCM in turn is going to power up various components based off of that. And again, if we go to, more modern vehicles than this 2006, a lot of times what I see is the ignition switch doesn't power up a single thing. It is just an input to a control module, and then the control module takes it from there. All right. And this might be pretty obvious to a lot of technicians, and if you worked on vehicles, you know this already. But I'll tell you what, when I go into shops, a lot of technicians struggle with this concept that the ignition switch is not the end all be all. Of course, it is, reflecting the driver's desire, what they want out of that vehicle, but the ignition switch itself isn't in charge of sending power to all these components. Okay, so now that we established that, what we want to find out is who is the power mode master, who is getting that input from the ignition switch and then actually sending power to components. And I mentioned it already, in this particular vehicle is the BCM, or body control module. Body control module is going to power up all kinds of different stuff, especially in a Suburban SUV. And, the BCM can go by various different names depending on the manufacturer, cabin compartment node, footwell module, whatever it might be. But in a lot of cases, our body control module is going to be our power mode master. It doesn't have to be. There are plenty of other vehicles out there where that's not the case. But even in those vehicles, we want to figure out who is the power mode master. Well, in this 2006 Chevy Suburban, my BCM, my body control module, is that guy. He's going to be getting a signal from the ignition switch and then in turn powering up various components based off of that signal. And this is where, sometimes techs can really go the wrong direction in their diagnosis when we have a component that's staying on. Like, let's just pick on the radio here. I've seen a lot of techs go straight for the component that is staying on. And okay, let's replace that component and see what happens. When we need to consider, who's in charge of turning on that component. And that's the direction that we need to go. And again, at this point in my diagnosis, I'm not going to go straight for my dash lights or my battery light or my radio. I'm not pulling the dash apart just yet. I want to go to the component that is in charge of turning those on and off. And now that I've identified what that is, I'm going to go in through my scan tool first, and I'm going to check out and see what's going on. So what I want to see in the BCM is what power mode we're in, and hopefully see what information, I shouldn't say information, what voltages it's getting from the ignition switch to determine what power mode we're in. Okay. Now, based off of what I'm seeing in the data PIDs, and this was really helpful, I could see all three inputs from the ignition switch to the BCM. So if you look at the BCM wiring diagram, it has several constant power feeds that are hot all the time, but it also has three switched battery feeds that all come from the ignition switch. And this is going to indicate to the BCM three separate ignition states. Okay, so you'd be off, then you have accessory, then you have run, and you have crank, and the ignition switch will feed voltage into actually multiple circuits at the same time, but depending on the key position, one or more of those might be off. And big thing for us right now is when the key is off, all three of those switched inputs should be off. That's what I'm looking for right now. Regardless of where they are when, doesn't matter to me too much right now. I just expect all of those to be off, all of those to be no voltage, right? Because the ignition switch's job, again, is to send voltage on these three circuits when the key is on. And I have the key off. I have the key in my hand, and I should see that there's nothing there. Well, of course, I see that two of them are indicating off or zero. There's no voltage. The third one, which says accessory, says active, says that it is getting a signal from that ignition switch. Now again, I have the key in my hand. It's not in the ignition switch. I verified that the switch is mechanically in the off position, but as far as the BCM sees, it is in that accessory position. So that would just be like clicking that lock cylinder, one position, putting it in the accessory position, and leaving it there. Of course, everything's going to stay on. It's not going to set a code. It'll eventually drain the battery, just like it is here. And that'll be the end of it. And so that's what the BCM thinks. Okay, this is what the driver wants, so that's where I'm going to leave everything. Now, my question is why? And so I'm inside the vehicle, and I figured the easiest place to go to do some testing is the ignition switch itself. All right, so I want to know, is there a short in this ignition switch? Now, of course, they replaced it already, and they actually had the shell for the steering column off, so this made it real easy to get to. So I just unplugged the ignition switch, and right away I can pretty much tell that ignition switch is not my problem. Of course, number one, they replaced it already, but once I unplug it, everything still stays on. All right, so my question in my head at first was, is the ignition switch shorting voltage when it's not supposed to onto this, what I came to find out was a brown wire? Is it shorting voltage onto this brown wire, causing the BCM to think that it's in the ignition or the accessory position? And it obviously wasn't, because the ignition switch is unplugged now, so there's no way it can send voltage to this brown wire. But now I have access to this circuit. Now, at least at the point of the ignition switch, I can do some testing here and see. Because again, unplugged, looking at the BCM data PIDs, it still says it's in the accessory position. Now, why does it think that? Is this a BCM problem? Maybe, but let's check and see what we've got on the circuit. So the first thing that I did was I grabbed my test light, and this is an incandescent test light, draws about 300 milliamps of current, and I clip it to ground, and I touch that brown wire. Again, this brown wire is the one that feeds the BCM for this particular circuit to tell the BCM that we're in the accessory position. As soon as I do that, as soon as I touch my test light to this circuit, everything shuts off. The radio shuts off, dash lights shut off, and the data PID in the BCM switches to off or inactive. I forgot what the exact terminology was, but it reflected where the key actually was at that point. Of course, I had the ignition switch unplugged, but everything turned off. And then I remove my test light, everything comes back. Okay, what's going on here? Not exactly sure, but I want to test this in a different way. So I grab my voltmeter and I put it on DC volts. I do the same thing. I ground the black lead of the meter. I put the red lead on this brown wire, and I'm measuring about 3.5 volts on this circuit. So what's happening here? And I should say everything stayed on. The radio, the dash lights, everything stayed on with my voltmeter connected, but with my test light, everything turned off. And this is an important note to make about what test methods and tools that we're using and how it's going to affect the circuit during testing. Really important to understand what you're doing with the tools that you're using. And my voltmeter is not loading a circuit down, at least not to a measurable degree. If you want to get real technical, yes, the voltmeter is loading the circuit ever so slightly, and that may have played a role as to why I measured 3 volts instead of battery voltage. But anyways, my test light has a bulb in it, and it's actually demanding some current flow in order for that bulb to light. But there is not enough current to light this bulb. There is too much resistance in this circuit, and when I connect my test light to this circuit, I'm basically just pulling everything down to zero. That entire circuit, that whole, wherever that brown wire goes, I don't know just yet, connecting it to ground through a bulb is enough just to pull everything down to zero. So it's something just to keep in mind, and just for any testing at all, really understand what you're doing, even when you're just connecting your test equipment. How am I affecting the circuit? And with my test light, I'm loading it. I'm actually loading that circuit, demanding some current. With my voltmeter, not so much. But what I do know is, at least measured with my voltmeter, I've got 3.5 volts on this circuit. With the ignition switch unplugged, I should not have that there. So it's time to look at a diagram to see where to go next. So I take a look at my diagram and I look at this brown wire as it leaves the ignition switch. And I want to see, where does it go? Who does it feed? What can I test next? Where am I going to go to next? And I look on my wiring diagram and I see that there are 4 fuses that are fed by this brown wire. and it is going to be the SEO accessory fuse, which I'm not 100% sure what that is at this point, the windshield wiper fuse, which is for the front windshield wipers, the rear wiper fuse, which is for the rear wipers, and then the TBC access fuse, which is the feed to the BCM. So what that fuse is, and that's important to take note here, is as the ignition switch powers up to this position, sends voltage down the brown wire, it goes through this TBC accessory fuse to the BCM, and this is where it indicates that, hey, we're in accessory mode, okay? Now this is the last fuse that I am going to pull. And maybe I didn't state that yet. My next step is I'm going to go to these 4 fuses. I'm going to pull one at a time and see when or if this circuit shuts down. Because what I'm thinking here is that there is voltage being fed back onto this circuit from another component that obviously shouldn't be, but it is. So usually, and now it could be a short from a wire. That's definitely possible. But the odds are that there's some component that is shorted, sending voltage back onto this circuit from the actual point where, current should be going. It's sending voltage back the other way because there's a short. And I want to identify where that is. Again, these 4 fuses are going to be my easiest point to isolate the basically 4 legs of this circuit. So I'm going to pull these fuses and I'm going to see which one kills everything, which one turns off the radio. Now, I can be fairly confident if I pull that fuse going to the BCM, I will shut everything off. Maybe not. Maybe the short's between that fuse and the BCM. Maybe the problem's the BCM, but I'm going to save it for last. So that leaves me with 3 fuses. I try the SEO accessory fuse, nothing changes. I try the rear wiper fuse, nothing changes. I pull the front wiper fuse and everything turns off. Okay, awesome. So now I have a pretty good direction on where I need to go. Because if you think of this in your head, and I realize it's kind of tough wiring just audio, but again, think of our ignition switch as the first point in this circuit, and then it has 4 legs. One of those legs feeds the BCM. 3 of those legs feeds other components. And when I mentioned earlier, the ignition switch in this case, it is an input to the BCM, but it actually does power up specific components. It's kind of a hybrid of the 2 methods I mentioned earlier. And these 3 legs of the circuit, we found the one that's sending voltage back up, kind of the wrong direction, but with everything off, it's power's power. It's going to send that 3 volts into the BCM, and that BCM is going to recognize that as, oh, hey, he's got the key on. Let's keep everything else on. Because I mentioned the radio and that sort of stuff is not mentioned in these circuits that I'm talking about. Again, that SEO accessory fuse may actually play a role, but the BCM can actually power up stuff as long as it thinks that key's on, which it's doing when it's getting power from this leg of the circuit, from the front wiper fuse. So we're going to go a little further on the diagram here now, and although the fuse is kind of self-explanatory, I do want to know exactly where this fuse goes. This front wiper fuse. What does it actually power up? Is it just the front wiper motor? Is that the only thing I need to check, or is there other things? Because one thing that I'm sure most of you know is that the name for a fuse, especially if you're just looking at one of the little fuse panels or even an owner's manual, may not be everything on that fuse. It might just list one thing that's on that circuit, and then there's another circuit that's not in the name of the fuse. So I always want to look at a diagram and verify, what are the potential, things that this fuse is powering up, and in my case, what are the potential components that could be sending voltage back, so I can verify them. So of course, as you'd imagine, it is the front wiper motor. That's one of the things that this fuse powers, but also the multifunction switch. All right. And again, I'm in the vehicle. I have the cover off the steering column. the first thing I'm going to look at is the multifunction switch because, hey, that could be a possibility. So the first thing that I do is I actually just kind of grab the switch and I move it around because this does turn signals, it does cruise control, it does the wipers, high beams, all that stuff in a multifunction switch, of course. So I move the turn signals, I move it through its cruise control settings, and I move it through the wiper settings as well. And I pulled back for high beams, and nothing seemed to happen. I did put the fuse back in here, and what I'm looking for when I do this is, does everything shut off when I move this switch? Is there a short to voltage from another circuit on this switch that's sending power back to this fuse? Now here's what I did find. When I moved the wiper speed to the high position, or the fastest position you could get the wiper arms to move, everything shut off. Okay, the radio shut off, the dash shut off. It's like the key was actually off. The data PID and the BCM changed. And again, I put the fuse back in for this once I identified the circuit. And again, with that switch in the high position, everything turns off. So I almost called a switch here. I did. And the service manager was actually kind of standing over my shoulder on this one. He was really interested to see what was going on and my path and what I took, which, I don't always prefer it, but whatever. He's a nice enough guy. And I almost called the switch. I was like, yeah, well, this got to be it here. And he was actually up ordering a switch before I could even finalize everything. But I'm like, hang on, let's just take a moment here to think, because there could be other potential problems. And this is another important note to make is, sometimes we can be in a rush. Sometimes we can just kind of get excited with these problems, especially if they're really frustrating. We finally get somewhere. We finally get something that shows, okay, this must be it. Don't call a component right away. Think about it for a minute. Think, is there any other potential reasons why this, could be happening? Is it this component, or is there something else involved with this component that's causing that problem? That's not always an easy question to answer. But here's what I like to do, and here's the way I like to think about it is, okay, find another way to prove out this component. My only way that I've really proved out the multifunction switch is moving it to the full high position turns everything off. But does that mean it's the switch? It might. That could be removing the short to voltage, but it might not. And I actually took a video of myself doing this. I'll put it up on the Facebook group just because it was kind of interesting. You could move the wiper switch from high to any other position and you could see the radio come on and off. But here's what I want to do. I want to find another way to prove out this switch. So how I'm going to do that, how I'm going to prove out this switch is I'm going to leave it in its high position where everything's off. The radio's off. The BCM is seeing that the key is in the off position, and I want to unplug this switch at that point, because what that's going to do is eliminate the switch from the circuit, basically. And if it really is the switch that is sending voltage on this circuit, then nothing should change. Everything should stay off. But if there's something else that's sending power back to this fuse, and my switch is maybe grounding it, just like my test light did. And that was my thought here. I'm like, wait, is my switch now kind of being like my test light where I'm grounding it out? Because we go back to when I unplugged the ignition switch and I touched the brown wire of my grounded test light, I shut everything off. Could my switch be doing the same thing here? And if I unplug the switch, while I have it in that high position and everything comes back on, I know that's what's happening. I know that my switch is actually grounding out that 3.5 volts, turning everything off, and that 3.5 volts is coming from somewhere else. So I do that. I unplug the switch while it's in the high position, while everything's off, and everything comes back on. Okay, so the multifunction switch unplugged, everything is back on. So what was happening was my switch in the high position was grounding out that voltage, killing everything just like I had done with the test light earlier. And after looking at the diagram, I understand why when you put it in the high position, it actually does ground a specific circuit going to the wiper motor, which is where I'm headed next. So I really only have one other place to go at this point. I go to my wiper motor. I have everything else plugged back in. I put the wiper switch in a low position, so the radio is stuck on again. Key is off. I unplug my wiper motor, radio shuts off. Of course, I'm asking myself the same question as I did before. Is the wiper motor not the problem? Is it something else? Of course, I want to test all the circuits going into this wiper motor. So I test all of them and everything checks out. I actually only have power on one wire, which is an orange wire, and everything checks out. I got my ground. I don't have anything else that looks wrong according to the diagram. But my question was, well, where is constant power coming from into this wiper motor? Because the actual power feed was the fuse that I removed that should only be powered up when the key's on. Where else is this thing getting power from? Well, it turns out the washer pump to actually spray fluid is the relay to control it is actually grounded through the pump, and it's sent constant battery feed. So you actually have constant battery feed through this relay coil into this washer pump all times. So that kind of has to be the power source that is shorted to, it was a yellow wire that goes back up into that fuse that goes to the ignition switch and also goes to the BCM. And again, if you look at the diagram, which I'll put a picture up of it in the Facebook group because I realize it's kind of hard to describe it. I'll make some annotations on it so you can see what I'm talking about. But to sum this up, there was a short to power inside the wiper motor, the front wiper motor, that was sending voltage back onto a circuit that was telling the BCM that the key was in the accessory position. And so the BCM was keeping everything on like you actually had it in the accessory position. So replace the wiper motor with a new one, fixes the problem. Everything turns off when it's supposed to. Key works, BCM's good. We can stick with the original one. We don't have to replace it. What they did with the rest of the components, I don't know. But car is fixed and we can move on. So hopefully you found that interesting, learned something from that, and it'll help you out somewhere along the line. I appreciate everybody listening. Thanks for tuning in. That's all I've got for you today, but make sure to check out the next tech tip and the next episode that I will have coming out later this week. Other than that, let's get out there, start fixing the world one car at a time.